Okay, so balancing of rotating masses and the high speed of engines and other machines is a common phenomenon nowadays, and it is therefore very essential that all rotating or reciprocating parts should be completely balanced. Okay, so rotating means when it is completely having the rotation motion, when the masses are having the rotation motion. Reciprocating means a type of piston arrangement where you can see in the engine parts there are reciprocating parts also, so that masses also to be analyzed there. And if these parts are not actually balanced, what will happen? The lot of forces will be generated, and that type of dynamic forces will be considered there. And these forces not only increase the loads on the bearing and stresses in the various member, but also produce unpleasant or even dangerous vibration, and this vibration will actually hamper the entire machine and it will fail that component. Okay, so these are the different aspects that you need to understand when the vibration is considered. So in this chapter now we will discuss about the balancing of the unbalanced forces caused by the rotating masses, and in order to minimize the pressure on the main bearings when the engine is running. Okay, so this vibration will actually cause a lot of noise also, lot of wear and tear also, and lot of failure of the component. Okay, so for that balancing is actually a must for this consideration. Let us see the different cases for this balancing where it is considered. We know that whenever a certain mass is attached to a rotating shaft, it exerts some centrifugal force, and whose effect is to bend the shaft and to produce vibration on it. Okay, so the centrifugal force, what it does, whenever there is a motion of a when there is with respect to mass, it tries to pull outwards. That is the centrifugal force. And in order to prevent this effect of centrifugal force, actually another mass is attached to that opposite side of the shaft. That is to counterbalance. Okay, and to balance the effect of the centrifugal force of the first mass, another mass will balance it. So this is done by such a method that the centrifugal force of both the masses are made to be equal and opposite. Okay, so the process of providing the second mass in order to counteract the effect of the centrifugal force of the first mass, balancing is being done. Okay, just now we discussed some examples. Okay, if the one side there is a more balancing, so automatically other side if you counterbalance it, the entire thing will be balanced. Okay, so there are again balancing with respect to different conditions, like balancing of single rotating mass with a single mass rotating the same plane. Okay, so they say it consider same plane. And the second case may be balancing of a single rotating mass by two masses rotating in different planes. Okay, planes may be different. And third case may be balancing of different masses rotating at same plane. So many masses in the same plane. And also there may be case when the balancing of different masses rotating in different planes. Okay, so these are the four different cases that we need to study for balancing, that we will be studying in detail one by one. Okay, so first we will consider the balancing of a single rotating mass by a single mass rotating in the same plane. Okay, so in the figure you can see one mass that is m1. You can see in the top side m1 is there, that is a disturbing mass, and attached to the shaft there, rotating at omega radians per second, that you can see in the figure. And let us take the radius as r1 there, that is r1 shown there, we can see in the figure. So r1 be the radius of rotation of the mass m1. So you can see the distance that is moved, it is r1 up to the for the mass m1. So the distance between the axis of the rotation of the shaft and the center of gravity of the mass, that is m1, that is the radius which is taken there. Yeah. And we know that the centrifugal force exerted by the mass m1 on the shaft, that is fc1. So centrifugal force generated by this, so that will be nothing but m omega square r. So first condition we can consider fc1 is equal to m1 omega square into r1. So that is the first equation. And this centrifugal force actually acts radially outwards and thus produces bending moment on the shaft. And in order to counteract the effect of this force, a balancing mass that is M2 may be attached in the same plane of rotation as a disturbing mass that is from to the M1. So same way you can see the dotted part now at the lower side. So at the same uh, level, at this same mass that can extra counterbalance can be added there, M2, and may be attached in the same plane of rotation as a disturbing mass of M1, and such that the centrifugal forces due to two masses are actually equal and opposite. Okay, so here it is extra there. So let us take the R2 as the radius of rotation of the balancing of mass M2, that is the distance between the axis of rotation of the shaft and the center of gravity of mass M2. So here the centrifugal force due to the mass M2 will be Fc2, that is M2 omega square into R2, and if we equate 1 and 2, because both should be equal, then only this will be balanced. So that will be if we equate 1 and 2, m1 omega square into r1, that will be m2 omega square into r2. So irrespective of this omega and omega will be cancelled because it will be having same thing. So we left out with m1 r1 equal to m2 r2. Okay, so here for this we consider m1 r1 is equal to m2 r2, that is condition. So the product m2 r2 actually may be split into convenient way, but the radius of the rotation of the balancing mass, that is m2, is generally made larger in order to reduce the balancing mass m2, and the centrifugal forces are proportional to the product of the mass and the radius of rotation of respective masses, because omega square is same for each mass. Okay, so this setup is there in the dynamics lab, and you're going to perform this experiment of balancing in 7th semester in dynamics lab. Okay, so there you'll be doing the experiment. There you can understand how this different balancing will be going to help when the masses are going to operate in different planes on the same plane. What are the things are there? Okay, so here there is a masses which are arranged, they are in the single mass which is there and in the same plane. Okay, so that why it was easy. So when you go with the different planes and all, automatically the calculation becomes more. Okay, so this is the consideration for using for the balancing of a single rotating mass by a single mass rotating in the same plane.